Hey, yo, 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 yo! I'm back, and hopefully, we'll be able to get through a video together right now. So let's get to it right away. Whoops. No. All right. So, ladies and gentlemen, we're going to talk about linear inequalities. So, linear inequalities. Here's your definition, and we say in two variables because we're talking about dealing with linear is with two variables x and y. So linear inequality is a set of all points that represent all solutions to an inequality. So inequality is when we're replacing the equal sign with an inequality symbol. So x is less than or equal to 4. Well, if I were to graph that, it would show me all of the solutions. So it would be at 4, we would have a closed circle. We'd be going to the left to show all the values left or less than 4 are a solution to that inequality. And this goes on forever. So we can't just say like 3 is the solution. We have to represent all of the solutions on a graph. So when we are working with linear inequalities, our solution is actually going to be a graph that's going to show the solution and show all the values that are possible values for both variables x and y. Let's just get to it so you can see what I'm talking about. So here I have a linear inequality. Okay, this is y is less than or equal to x minus 1. So instead of an equal sign, I have an inequality symbol. But we treat this as if it is an equation. We treat it the same as if it's an equation. We're still going to graph it. We're still going to graph using our slope and using the y-intercept. So the graphing process is no different. So what we're going to do to find the solution, we're actually going to graph this on a coordinate plane. And then we'll get to, well, how does this show all the solutions of the inequality? So I'm going to graph this on a coordinate plane by starting with my y-intercept, which is -1. So there's my y-intercept of -1. My slope is 1, so I'm going to go up 1 over 1, up 1 over 1. And there's my line. I can go down 1 over 1. It is important to go both directions so we can show what we're doing here. Now I can connect all of these points. Now with inequalities, it does matter how we connect the points, whether we use a solid line or a dashed line. So at one point in time, I've had you guys draw these faces. Faces that look like this. So if we have, whoop, ooh, that was a spaz attack on the pen. We're okay. So faces that look like maybe you have your eyes, and then there's a closed circle for a nose and a solid line for a mouth. So if you have these inequality symbols, then you're going to use a solid line. If you have the or equal to, you're going to use a solid line on your graph. If we have the not or equal to, so if it's just less than or greater than, we used an open circle on a normal graph when we're graphing it on a number line, and then there is a dotted line for the mouth. So therefore, we would use a dashed line if this did not have the or equal to symbol, because we use a solid line to show that everything on the line is also included in the solution, because if it's equal to it and it's on the line, that's part of it. So a solid line means it's included, dashed line means it's not included. So right now I graph my line. I have a solid line because I have an or equal to symbol. So an inequality though, I'm looking for all the points that are less than this particular line. Okay. So what we're actually going to do is there's a lot of y's and x's that'll be solutions for this inequality. So everything that's less than is going to be below the line. So what I would do is I'm actually going to shade all of the solutions below the line. And we'll use blue as our highlighter. And I would just do a nice light pencil shade to shade in all these solutions, showing that everything below the line is a solution to this inequality. And let's show you what I'm talking about. So what I can do is I can pick any point. I like to test the point 0, 0. Now I know 0, 0 is not part of my solution, but I'm going to show that 0, 0 isn't part of my solution, which means I shaded on the correct side. So if I plug in 0, 0, the reason why I choose 0, 0 is it's really easy to do math with 0, 0. If I solve, is 0 less than or equal to -1? Is that a solution to this inequality? The answer is no. 0, 0 is not a solution to this inequality. So therefore, 0, 0 is not a solution. So that means it can't be in my shaded region, because everything that's shaded is a solution to the inequality. So now let's look at the point, any easy point that's in the shaded region. I can pick the point, I don't know, let's look at this point, 2, 0. Okay, well, y is 0 is less than 2 minus 1. So is 0 less than or equal to 1? And yes, that checks out. This is a solution to this inequality, this combination of points. So if I were to take any point that is below this line, so any point that's below this line, it would, when I plug it in as y and x, it would actually work out and it would be a solution to the inequality. So that's why we shade, because the shading is showing me all the possible solutions. Okay, this point right here, this would be a good solution for this inequality. So with this point, so with this point, so with these imperfect points, it doesn't matter. Everything below infinitely on this side of the line would be a solution. So whenever it's less than, we go below. Whenever it's greater than, we go above. But my recommendation is always to test one point to make sure that you shaded correctly. Okay. So now you might have some word problems. Okay. So the Science Club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? So what we would want to do is we want to start off with an inequality. So they have a $500 goal. Okay. Now, $500 goal, they want to sell t-shirts and keychains. So they're selling t-shirts and keychains, $10 each, $2 each. There's a lot of possible combinations they can sell in order to get to that $500. So I know they sell $10 for every t-shirt and they sell $2 for every keychain. When I add those up, I want to be at least 500. Now the difference is I want to be at least 500, not equal to 500. So at least would mean that this left side has to be greater than or equal to 500. So if they make more, that's okay. They met their goal. Okay, but they can also exceed their goal. So this is the equation that I'm trying to graph. So now you can graph it by using the intercepts. That would be totally acceptable. So let's make a graph here. Okay, because then if I graphed using the intercepts, I'm going to replace now, we'll use X for t-shirts, we'll use Y for keychains. So we can replace t-shirts with X. And we can replace keychains with Y. Okay, so now what I can do is I can graph by finding my intercepts. So when I plug in 0 for Y, for X, that means I'm going to have 50. So my X intercept is 50. My Y intercept is going to be, let's see, well, it's $2 for a keychain, so I got to divide 500 by 2. That's 250. So I think an acceptable graph here would be to count by 50s, is what I'm going to do, I think. So I'm going to count by 50s. I'm going to go 50. I could have counted by 10s, actually, especially in my X values. Maybe that would actually be better. Maybe we should. Yeah, so I'm going to change this, and I'm going to count by, oops, I don't know how that got there. I'm going to count by 10s. So I'll go 10, 20, 30, that's 40, and that's 50. So my x-intercept is here at 50. And then for my y values, I'll use this graph to count by 50s. So my y-intercept is here at 50. So now I've got my 2 points. I'm going to connect them with a solid line because it has the or equal to symbol. So there's my solid line. So then because I need it to be greater than or equal, I need to make more money than this line. If I sell anything less than this line, like so if I were at this point here, if I sold 10 keychains and 200 t-shirts, that would not reach my goal. So I need to be above the line because I need to be greater than or equal to my line. So everything above would then help me either meet or exceed the goal. So everything on the line would help me meet my goal exactly at 500. Everything above the line would then help me exceed my goal, which is fine. We can always go do better than the $500. So there's my graph to this inequality. Now you're going to have some where it's just X and Y without having 2 variables, and you'll have it with just 1 variable. Well, we solve it as if, again, it's just like X equals or Y equals. So for X equals 3, we always had a vertical line at 3. So that'd be 1, 2, 3. So I'm still going to put a vertical line here at 3. I am going to do, that is one ugly line here. Let's start that one over. I just can't. It was like 2 lines. 1, 2, 3. There we go. That's better. I'm using a solid line because it has the or equal to symbol. And so I'm trying to show all on the graph all the possible values for x is greater than 3. Well, for x is greater than 3, every point on a coordinate plane that's greater than 3 is going to be to the right of 3 because everything greater than 3 is over here. So I'm going to shade onto the right side. So there's my light pencil shading on the right of the line, and I'm done. Y is less than 2. So I'm going to graph it just like it was y is equal to 2. That's right here at y is 2. It's a horizontal line, but because there's no or equal to, I'm going to put a dashed symbol because that means that everything on the line is not part of the solution. Because everything on the line is y is 2, and it has to be less than 2. So that's why it won't work. But everything below this is part of my solution because everything below y is less than 2, or below line y is equal to 2 is less than 2. So these are all the values that make y is less than 2. You might also have to write an inequality by looking at a graph. So if I look at this first one, first thing I want to look at is I want to look at, do I have a solid line or dashed line? If it's dashed, that means I'm not going to have the or equal to. Then I have to actually write the equation of the line. So I have to figure out my y-intercept. Okay, so my y-intercept is 0, so that makes it easy. And then I got to figure out my slope. Well, I go up 1 over 3, because here's a perfect point right here. So my slope is 1/3. And I don't have a y-intercept because it's just plus 0. I don't need to write that. But because everything's below the line, it's going to be y is less than, not or equal to. I messed up. So it says y is less than 1/3 x. And I'm already done. There's nothing else I need to do here. Okay. And if I wanted to check a point to make sure I did this right, I would check, like, I always like to pick a point that's going to be easy math. So if I checked this point right here into this inequality, that means if I wrote this inequality right, this point would be a solution because it's in the solution set. This point would be a solution to this inequality. Well, so that's y is 0, x is 3. Is 0 less than 1? Yes, it is. So that means I wrote my inequality correctly. Go ahead and try this one. So pause it, see how you do. Try to write your own inequality. Okay, so solid line means I have the or equal to included. Y-intercept is 1. I need to find my slope, so I got to find another perfect point. So we're going down 2 over 1, so it's negative 2x. And it looks like we're below the line. That's y is less than or equal to negative 2x plus 1. Now, I'm going to check a point to make sure I didn't mess it up. So I'll check 0, 0. 0, 0 whenever is actually something I can check. I couldn't check 0, 0 here because it's on the line. We always want to check something below or above the line. So I'm going to check 0, 0 to see if it works. So 0, 0, if I plug it in as x and y, that makes it go away. 0, 0 is really easy math to work with. 1 is greater than 0, so therefore my solution was good. Okay, worked out. And so that means I did my inequality correctly. There's my inequality. Okay, try this one on your own. I believe this is the last one. Yeah, so try this one on your own, pause it, see how you do, graph the inequality, check your line, check your solution. Okay, so here's the inequality. So I started at positive 5, had a slope of negative 3, down 1 over 1, and I used a dashed line because there's no or equal to symbol. But I still haven't shaded yet. So now I'm going to work on the shading. And the shading, because y is less than, it's going to be below the line, which is going to be on this side. Now, again, if we have a hard time realizing if it's below or above, check a point. And the point test will make sure that you do it right every time. So I can always check the point 0, 0. Does 0, 0 work? Well, let's see. That goes away. Is 0 less than 5? Yes, it is. So therefore, 0, 0 is part of the solution. So I shaded on the correct side of the line. Every single one of these points would work. I don't know why I keep doing that. So every single one of these points on this side works. So this is all the possible solutions for this inequality. Okay, that's it. Remember, and for things to remember, I would draw those faces again, please, in case we haven't. Those aren't the faces at all. So I would draw the faces because that's probably one of the most common mistakes, forgetting when to use a solid line and when to use a dashed line. Okay, so we have or equal to symbols, we use solid. When we don't have or equal to symbols, we use a dashed line. Okay, you can make the faces cool if you want to. All right, that's all I got for you guys. I hope this helped. Thanks for watching. Good to see you out.